write the variance of first and natural numbers. We know that variance of variable x is equal to 1 upon n summation xi square, that is from I is equal to 1 to n, minus summation xi upon n whole square, where I is taken from 1 to n. So let us consider the observations. Take x observations and square of the observations. Let us consider so observations are natural numbers, n natural numbers, 1, 2, 3, 4 and so on, n minus 1 and n natural numbers are there, and square of the observations. So we can say 1 square, 2 square, 3 square, 4 square and so on, n minus 1 whole square and n square. And we required summation of xi and summation of xi square. Sum of xi is nothing but sum of the observations, that is x1 plus x2 plus and so on xn, that is 1 plus 2 plus 3 plus and so on n. It's a sum of first n natural numbers. We had a formula, sum of n natural numbers is n into n plus 1 upon 2, and then summation xi square, where I is equal to 1 to n, that is x1 square plus x2 square plus and so on xn square, which is equal to 1 square plus 2 square plus 3 square and so on n square. Sum of the squares of first and natural numbers. We had a formula n into n plus 1 into 2n plus 1 upon 6. So let us substitute xi and summation xi square in the formula of variance. So variance of the observations, that is variance of x is equal to, that is sigma square is equal to 1 upon n summation xi square minus summation xi upon n whole square, which is 1 upon n into summation xi square is n into n plus 1 into 2n plus 1 upon 6 minus summation of xi is n into n plus 1 by 2 into n whole square. So we can cancel here n and n, and here also n and n get cancelled. So which implies, which is equal to n plus 1 into 2n plus 1 upon 6 minus n plus 1 whole square upon 4. So LCM of 6 and 4 is 12. So let us take 12 as LCM. So 6 2 times. So, and also we can consider n plus 1 common. N plus 1 upon 2, and here 2n plus 1 into 2 times, and again minus, here 4 3 times and n plus 1 is taken common, so 3 times of n plus 1. So which is n plus 1 by 12 into, here we can write 2 2s of 4n plus 2 minus 3n minus 3, which is equal to n plus 1 by 12 into 4n minus 3n is nothing but n, 2 minus 3 is negative 1. So n plus 1 into n minus 1 is nothing but n square minus 1 divided by 12. So variance of the given observation set of first and natural numbers is nothing but n square minus 1 upon 12. If the sum of the squares of deviation for 10 observations taken from their mean is 2.5, then write the value of standard deviation. So let us consider x1, x2, x3 and so on x10 other 10 observations, and their mean be x bar. So sum of the squares of the deviation for 10 observations from the mean is given 2.5. So we can write x1 minus x bar whole square, that is summation of xi minus x bar whole square, which is nothing but x1 minus x bar whole square plus x2 minus x bar whole square plus, and so on up to 10 observations. So I is equal to 1 to 10. So x10 minus x bar whole square, and we know that variance of variable x is equal to variance of the variable x is equal to sum of the squares of the deviation from the mean, that is summation xi minus x bar whole square upon the number of observations. So which is equal to sum of the squares is given how much, 2.5. So we can write this is 2.5 divided by number of observations is 10. So 2.5 upon 10 is equal to 25 divided by 100, that is 1 by 4. Hence variance of variable x is equal to 1 by 4, that is sigma square, and then standard deviation sigma is equal to under root of variance of x, the variable, that is under root of 1 by 4, so which we can consider 1 by 2. So square root of 1 by 4 we will take 1 by 2, that is 0.5. So standard deviation answer is 0.5. If x1, x2, and so on xn are n values of a variable x, and y1, y2, and so on yn are n values of variable y, such that yi is equal to axi plus b for I is equal to 1 to n, then write variance of y in terms of variance of x. So here given x1, x2, and so on xn are n values of variable x, so that their mean is equal to sum of the observations divided by number of observations, which is taken x bar. And we know that if each observation is multiplied by a constant say a and added with another constant b, then their mean will be considered to be aX bar plus b, means mean is also multiplied with a and added with a constant b. Since the variable y given y1, y2, and so on yn are n values of variable y, which is in connection with the variable x, that is ax1 plus b comma ax2 plus b comma and so on axn plus b, these are the values, so that we can consider their mean, means each observation is multiplied with a and added with a constant b, so we can write their mean is equal to sum of the observations, so that is aX bar plus b, so it is nothing but sum of the observations, sum of the yi divided by n. Okay, next, then variance of variance of the variable y is equal to 1 upon n summation of yi minus y bar whole square, that is 1 upon n times of summation of yi is nothing but axi plus b minus the mean of the variable y is ax bar plus b the whole square. So it on simplifying we can write 1 upon n times, we can remove the brackets and we can write summation of axi plus b minus ax bar minus b, plus of minus is minus b the whole square. So we can cancel b and b and we can take out a common, summation a times of xi minus x bar whole square. So we can also write square for a. So a square is independent, we can take outside and we can write a square into summation of xi minus x bar whole square divided by n. So which is nothing but it's a sum of the squares of the deviations of the variable x from the mean is nothing but variance of variable x. So we can write a square into variable of the variable, variance of the variable x. So we can write this variance of y is equal to a square into variance of x. So we can just remember, if the variable y is in the form ai x plus b and if it's connected with x, sorry, axi plus b, if the variable is y is connected with x in such a way that axi plus b, then the variance is connected by variance of y is equal to a square into variance of x. So this is a standard property we can remember. Okay. If x and y are two variates connected by the relation y is equal to ax plus b upon c, where a, b, c are constants, and variance of x is equal to variance of the variable x is equal to sigma square, then write this expression for the standard deviation of y. So we can write the variate y is equal to a upon c of x plus b upon c, so which is in the form of ax plus b, since we know that if any value of the variable y is connected with the variable x in such a way that yi is equal to axi plus b, then the variance of the variable y is equal to a square into variance of the variable x. So here we can write the variable y is connected with x in such a way that the coefficient of x is a upon c. So we can write the variance of y is equal to a square, that is the coefficient of x whole square, that is a by c whole square into variance of the variable x. So we can write mod of a by c whole square also, mod of a by c whole square into variance of x is nothing but sigma square, and hence the standard deviation is equal to standard deviation of variable y, standard deviation of variable y is equal to square root of variance of y. So we can write which is equal to square root of a by c whole square into sigma square, that is mod of a by c into sigma. So we can say that standard deviation of the variable is mod of a by c into sigma. Okay. In a series of 20 observations, 10 observations are each equal to k and each of the remaining half is equal to negative k. If the standard deviation of the observation is 2, then write the value of k. So here the observations are 20 observations. So 20 observations in which 10 observations are K. So K and so on 10 times K, and the remaining are negative K and so on negative K. These are remaining 10 observations. So total 20 observations are given. Then we can say very clearly the mean is equal to sum of the observations. So here 10 times K plus 10 times of negative K upon 20, which is 10K minus 10K is 0. So 0 upon 20 is 0. So the mean of the given observations is 0, and the variance of the observations, variance of the variable, let us consider x is equal to, so we can write sum of the squares of the observations from the mean. So that is 1 upon n summation of xi, that is each observation. So we can write it as k minus 0 whole square plus k minus 0 whole square and so on 10 observations, and again negative k minus 0 whole square plus and so on negative k minus 0 whole square, remaining 10 observations. So which is equal to 1 upon n times 1 upon 20 we can write. So here are 20 observations. So 1 upon 20 times of, so here k square plus and so on k square, and again negative k whole square also we can write k square plus and so on k square. So total 20 times k square we can write, which is equal to 1 upon 20 times k square. So we can cancel this 20 and 20, and it's given that the variance, the standard deviation is given 2. So variance is equal to k square. So standard deviation is equal to square root of the variance is equal to, which is given as 2, that is root over k square is equal to 2. So we can write k is equal to squaring on both sides, so we can write k square is equal to 4, or k is equal to plus or minus 2. If each observation of a raw data whose standard deviation is sigma is multiplied by a, then write the standard deviation of the new set of observations. Let us consider x1, x2 and so on xn be the n observations. With the n observations of raw data whose standard deviation is sigma, and let us consider if each observation this is multiplied by a, so ax1, ax2 and so on axn be the new observations, new set of observations. Let us consider to be y1, y2 and so on yn. So here yi is connected with a variable xi such that each observation is multiplied by a. We know that if any variable y is connected with a variable xi in such a way that it's multiplied with a and added with a constant, then variance of the new variable y is equal to a square, that is coefficient of xi, a square into the variance of the variable x. So we can write here variance of the new variable, so let capital Y be the new variable, is equal to a square into variance of x, that is the old observation. And we know that, let us consider the standard square root of it. Square root of variance of y is equal to square root of a square into variance of x, that is square root of variance of y is nothing but standard deviation. So standard deviation of y variable, standard deviation of variable y is equal to square root of a square, so we can write mod a into square root of variance of x. This is mod a into root over variance of x, that is square root of variance of x is nothing but standard deviation of variable x. That is, it is given standard deviation of variable x is given as sigma, so mod a into sigma. So standard deviation of the new variable is nothing but mod a into sigma is the answer. If a variable x takes values 0, 1, 2, and so on n with the frequencies nc0, nc1 and nc2 and ncn, then write variance of x. So given observations 0, 1, 2 and so on to n, and given the frequencies, binomial coefficients, the frequencies are given, binomial coefficients nc0, nc1, nc2 and so on ncn, and then to find the variance for discrete frequency distribution, the variance of the variable x is equal to 1 upon summation of fi into summation of fi xi square minus summation of fi xi upon summation of fi whole square. So let us use this formula. So let us find fi xi. Let us consider fi xi, that is 0 into nc0. For some, let us consider ncr to be written cr into c0 we can write, and nc1 we can write c1, so 1 into c1 and here 2 into c2 and so on n into cn, where cr is denoting ncr. And let us consider xi square, so we can say 0, 1 square, 2 square and so on to n square, and then fi xi square, so that is nc0, that is c0 into 0, that is 0 into c0, and 1 square into c1 plus 2 square into c2 and so on, we can get n square into cn. Now let us find summation of fi, which is equal to nc0, that is c0 plus c1 plus c2 and so on cn. We know that sum of binomial coefficients is equal to 2 to the power n. So let us use this. Summation of fi is equal to 2n, and then summation of fi xi is equal to 0 into c0 plus 1 into c1 plus 2 into c2 and so on n into cn. And from the properties of binomial theorem, binomial coefficients, we can say summation of r is equal to 1 to n or 0 to n. We can write r into cr is nothing but cr means ncr, which is equal to n into 2 to the power of n minus 1. So we can write here n into 2 to the power of n minus 1, and then summation of fi xi square, summation of fi xi square is equal to 0 into c0, that is 0 square into c0 plus 1 square into c1 plus 2 square into c2 and so on up to n square into cn, which is given by, we know that summation r is equal to 0 to n r square into cr, which is equal to n into n plus 1 into 2 to the power of n minus 2. So you must remember these properties to solve this problem. So which is given by n into n plus 1 into 2 to the power of n minus 2. So let us substitute these things in variance. So let me write the formula variance. Variance of the variable x is equal to 1 upon summation fi into summation fi xi square minus summation of fi xi upon summation fi whole square, which is equal to 1 upon summation fi is nothing but 2 to the power n into summation of fi xi square is n into n plus 1 into 2 to the power of n minus 2 minus summation of fi xi is n into 2 to the power of n minus 1 n into 2 to the power of n minus 1 upon summation fi is nothing but 2 to the power n whole square, which is equal to, so we can write it as 1 upon 2 power n into n plus 1, that is n square plus n into 2 power n minus 2, we can write 2 power n upon 2 square minus, here we can write n square into, so here also we can write 2 power n upon 2 into 2 power n whole square, that is 1 upon, here 2 power n gets cancelled, n square plus n upon 2 square is 4 minus n square into, here 2 power n get cancelled, so 1 upon 4. So upon 4 n square plus n minus n square, so n square get cancelled, so we have the answer n upon 4. So therefore the variance of the variable x can be considered n by 4. So we need to remember these properties. Sum of the binomial coefficients is 2 power n and summation r is equal to 0 to n r into cr, that is equal to n into 2 power n minus 1, and summation r is equal to 0 to n r square into cr is nothing but n into n plus 1 2 power n minus 2. Okay.